Hello, thank you. Welcome to Discovering Descriptors. Let me tell you that first, I'm not the only one who's very fond of descriptors. You'll find that many core developers will also tell you how good descriptors are. And the reason is that they're not only a very powerful feature, but they're also a fundamental part of Python itself. On the next of the slides, we'll see examples of both things. So by understanding descriptors, you'll understand Python better and appreciate more things and be more proficient. But first, something that applies to all programming languages in general that support object orientations in some ways. Basically, we have objects that are instances of some class, and they hold attributes, which hold values. Basically, when we request something, one of the attributes, we pretty much get what was previously set there, so there's no surprise there. But what if I told you that when you try to request one of the attributes, you can also run arbitrary code that is going to be run by another object of a completely different class? So basically, that's the first idea behind descriptors, that they are a feature that enable us to control the core level operations at the very low level when we try to perform one of the basic operations over attributes of an object that implement the descriptor protocol. Basically, that we can control what happens when we try to get, set, or delete some attributes of that object and have full management of that. So basically, a descriptor is an object that implements the descriptor protocol, which is just a bunch of methods that, as always in Python, they're magic methods, which is the common way of achieving functional, special functionality. And basically, this is, for example, the underget, the underset, the underdelete, and the underset name, which added in the last version of Python, namely 3.6. So this is also not discovering descriptors, but perhaps rediscovering descriptors. So even if you were familiar with descriptors before, it's usually a good idea to take a look at what's new in the last version of Python, because there have been some enhancements that make things nicer. So basically, there are two types of descriptor: data descriptors and non-data descriptors. And the difference is that if they implement underset, they're going to be a data descriptor, also known as overriding descriptor. And this sort of descriptor completely take over and take precedence over the dictionary of the object instead, whereas non-data descriptors don't. So first, the dictionary of the object is going to take place, and then the descriptor itself. So let's see this, an example of both with some code. So imagine that I need some formatting in order to automatically compute things based on other properties of the object. Basically, it's pretty much like a property, but I need to repeat the code many, many times. So I am going to have an object that has some attributes that hold datetime values, and I want to format them as a string. And I want to reuse and have a single logic. I'm going to implement a descriptor. So when it comes to the descriptor, we generally are talking about two classes at least. One for the descriptor itself, that is going to encapsulate the logic I want to achieve. And the other, which is the manage class, which is the original class we intended to have in the first place, the one that the user is going to be interacting with. So first, let's see the descriptor. Basically, I'm going to have a class like this, which I'm going to call dateFormatter, which is going to handle this logic of formatting a date into a string. And I'm going to define the underget. And based on the definition we just saw when we took a look at the methods of the descriptor, since it implements one of the methods that is part of the descriptor, this object is going to be a descriptor. And this object, dateFormatter, is created with a name that is held internally in order to know the name of the variable that it's going to be managing. And then in underget, what it does, it will try to get that value from the object that is managing, and it's going to compute the formatting doing the string format of the datetime, and it's going to return that. Now, let's see how this is used in the manage class. Basically, I'm going to have this object that, suppose I'm in charge of a Unix file sort of object that basically has a file name. I'm interested in seeing when was created, when was last modified, and if it was removed. So I'm going to have, for example, created at, updated at, and removed at, which are going to be regular attributes of the instance. But then I'm going to have str created at, str removed at, etc. that are going to be class attributes. And this is important for the descriptor protocol to work. They have to be defined at the class level, so they have to be class attributes. Otherwise, the mechanism won't work. And basically, I'm created instances of the previous class, which I saw, that are descriptors. I'm going to pass in the name of the attribute that I'm going to manage in. So now, if I create one of these objects, for example, I create filestat, and I provide all the parameters to it, for example, created and updated, there are instances of datetime. When I request str created at, I get the string representation of the same value. And basically, what's happening is that the descriptor is taking place behind the scenes, and it's formatting based on the code we just saw in the first line. So let's try to understand in which order things were resolved in order to get to this result, to this string. So first, I created the object, and I passed all the parameters to it. And I requested for an attribute under the name str created at. So Python will first look into the dictionary of the object looking for a key under the name str created at. And as it happens, it's not there, because the object has something which is created at that is not the same. So the search failed, the first search fails. Okay, no problem, Python will continue, and this time it's going to look into the dictionary of the class, and the key is going to be there. So it finds a key that I'm requesting, and it has an object which is an instance of the descriptor. So you think, okay, then it's going to return the value for that key because it has found it. Well, not exactly, because Python is smart enough to identify that this is a descriptor because it has an underget method. So if it does so, it's going to return the result of the underget, and that's why we're getting the result. So basically what happened here is that when we call something like str created at, it was actually calling the class.descriptor.getUnderget, and it's going to pass the object as a first parameter and the class as a second parameter. And in that method, we deliberately put the logic of formatting that attribute and returning that result. This happens when it's called from an object. There's a special case when it's called from the class. So if you call the class.descriptor, basically in that case, instance is none, which is instance is the first parameter of underget, which in general is the object that is going to be modified. If you call it from the class, it's going to be none, and in that case, it's customary to just return the entire descriptor object. Similar to when you have properties, then if you decorate something with a property and you call it from an object, you get the result of the property, of the method that the property decorates. But if you call the property from the class, you get back the property object entirely. This is somehow similar, and we'll see why near the end. So let's see how the descriptor got its name, because basically the descriptor usually needs to store the name internally in order to need the name of the key that it's going to be modifying or changing if we need to. So basically, here we pass it explicitly. I had to repeat part of the name in order to tell when I created the object, which is an instance of the descriptor class, the name of the property of the attribute that is going to be modifying in case it's in the dictionary. So for example, for str updated at, I had to pass updated at, telling the descriptor you're going to be modifying the attribute under the name updated at. But I want something like in the last example, something like str remove at, and I want to just simply create a descriptor and don't have to worry about passing the name another time. I want this to have automatic configuration. So if you wanted to do this on previous version of Python, you had to resort to some techniques, for example, having a class decorator, and inside the decorator of the class, putting the logic of mapping the name with the descriptor or checking if it's instance of a descriptor and setting the name. Or another option was to use a metaclass, which also seems like too complicated when you're creating the class to set the name automatically. But luckily in Python 3.6, there were some enhancements on how classes are created, and under setName was add, and basically it receives the class as a first parameter, which is owner, and then the name, which is the name of the attribute as it appears defined on the class. And this is going to be called automatically, and inside that method, we can just store the name internally or do some kind of transformations if we need to, and it's much more convenient. So basically, this way, we automatically set the name of the attribute we're going to be changing. Now let's see something like relates to modifying data and using descriptors. And for this, we're going to see some data descriptors. Basically, suppose that I have a problem that I have some attributes defined in an object, and I want to automatically count or keep track of how many different values that have been changing over time. So I devised some strategies by I can use this. And again, in Python, there are many options or ways to solve it. For example, I could use a property and define the setter, and in the setter, keep track of how many times it changed the value and update the counter. I can use the same by overriding setAtter, and that might also work. But actually, the first two options are not quite extensible, or if I want to extend them and make achieve something that is completely generic, I'm going to run into issues, or the code might get complicated. So we see how with descriptors we can do it in a much easier way. So first, I'm going to create this class, which is called trace property, and basically it's in charge of counting how many times another attribute changed its value. And in the name, I'm going to store two things. One, which is the name, as always, the name of the attribute that it's taking place. And another, which is count underscore name, which count how many times name had changed their value over time. And just for simplicity and for the sake of the example, I'm going to assume that everything that starts with count underscore is under this logic, and that we're not interested in tracking things that start with count underscore. So now, okay, now we have the name. Now we know the descriptor knows how to be, what things are going to be changing on the object that is managing. And now in the under set. And basically, what it does is, I'm going to try to get the value from the dictionary of the object. If it's not there, it means there's nothing, so the count will set it to 0. If it is there, I'm going to compare the value that I'm currently setting to the value that it already has. And in case it's different, I'm going to update the counter incremented by 1. And in any case, I'm going to update the value with the value that is received based on what the user is setting. So in order to illustrate that, suppose that I have an object that it's a tourist or traveler. I'm interested in seeing how many different cities and countries has a person visit. So I'm going to have an object like this, and I'm going to define city, country to be instances of trace property. So when I create one of these objects, and I first set the city, both counters are in 0. And when I change the city to something different and the country, we know that there's a count city and count underscore country that are incremented by 1. And the same happens if I try to change something to the same value that already has. But basically, what's happening is that behind all of these examples of this code, the previous code is taking place. Basically, every time we're trying to do one of these assignments, the logic of the descriptor is taking place. We're in full control of what happens there. So basically, this is also syntax sugar for when we call something and we try to cite a value to something that is a descriptor and implements it under set. Python will translate that and will call the class .descriptor.underset, and we'll pass the object as a first parameter and the value we're trying to set as a second parameter. And in that logic, we're in full control of what's going on, so we can adapt that according to our needs. By this point, it's becoming rather clear what under delete does. Basically, yes, you must have s is what's going to be called when you try to delete something or issue the del statement in something that is a descriptor. So imagine that I have one object that I want to protect some attributes on it. One way of doing so would be I'm going to create a descriptor, and in under delete, I'm going to raise an exception saying that you can't delete this attribute. So suppose that in my application, I define the user of my application, and I want the username to be protected. So the rest of the attributes are just regular attributes in Python, but the username can be removed. So because this is under this logic, and username is an instance of the descriptor, when I try to delete it, it will raise an exception saying you can't delete the username for this object. Whereas if I try to delete something else, it will just let me because it's a regular variable. So this is the difference between descriptors and regular attributes of objects. So now we know the basics of descriptors. We have seen the methods that they have and some brief examples of how can we use that to our advantage. But how do we know that we're making sense out of descriptors and that we're using them in a good way? So basically, a good descriptor is like any other good Python object. It has to be consistent with Python itself, or what we call to be Pythonic. So probably a good idea to identify if a descriptor makes sense with Python is to take a look at how descriptors are used internally by Python itself. Because as it turns out, descriptors are pretty much everywhere in Python. For example, properties are actually descriptors. They're implemented in C, yes, that's true, but you can find equivalent implementation in Python of how the script properties work. Remember that at the beginning of the presentation, I mentioned something that was suspiciously similar between properties and descriptor. I mentioned that when you call the property from the class, you get the entire property object. And when you call the descriptor from the class, you get the entire descriptor object. Well, this is because actually properties are just one particular case of descriptors. When you wrap something with property, the object is stored that internally, and will run that in under get. The same happens when you decorate something with add property.setter, we'll store that method and we'll use it to run in under set, etc. Also, class methods are descriptors, and basically what they do is basically they define under get, and they make sure that they provide the class as a first parameter, and also static methods. And probably the best or the nicest thing in whole Python, in C Python at least, is methods, because methods work thanks to descriptors. Because in the end, methods are just functions. And functions, in turn, are descriptors that can be that are used in order to transform that to a method bound to an object. So basically, methods have an underget method, so therefore they are non-data descriptors. And what they do in underget, they receive the object, remember, and the class, and they return the same version of that function with the object applied as a first parameter, which is what we call a bound method, which is a function bound to an object. So first, let's see that functions, the methods are just functions. So I create the class, and what we find is something with def and a name inside the body of the class, and this is what we know of methods. But if we inspect the dictionary of the class, we see that internally it's stored as a function. And even if we check the type, that confirms it. So what happens is that, remember from the first example, when we have something defined at the class level, that is a class attribute, and has an underget method, Python doesn't just return the object just yet. Instead, it calls the underget of that object and returns the result of that. So with that idea in mind, with these two concepts in mind, we know that when we're actually calling method, we're never calling the method directly. Because when you call instance and the method, this is actually a descriptor, so it will call the underget on that object. The underget is going to return the function applied to that object, as a callable, so then the rest of the arguments follow. So basically it's calling the class dot the method dot under get, passing the object and the class as a second parameter. That returns a callable, which is the same function with the object pre-applied, like doing partial application, and then follow the rest of the arguments. So basically, descriptors have been there all along, perhaps hidden in plain sight, and we're using them. Now let's see what else we can use with descriptors, because it turns out that there's lots of many other uses that we can make of our descriptors. For example, probably the best thing about descriptors is not only they are so powerful, but maybe that they can help us improve other areas of Python itself. For example, fixing the decorators. For some decorators, I change the signature of the function. And we'll see that this might be like a hard problem, but it actually has a very simple solution. So for example, suppose I have lots of functions in the code like this one that I call resolvers, and they take 4 arguments. Am I always creating an object which is part of my domain of an internal framework with those parameters, and then the rest of the logic only uses my internal object and I don't need the parameters anymore? But there are many instances of this, and then it's repeated all over the place, so I want to remove some boilerplate. I'm going to create a decorator. Basically, what it does is it's going to take care of this for arguments. It's going to create the object, and it's going to pass the object already created to the wrap function. So now I can redefine my function to assume that it's going to receive the object already created and need it to work with nothing else. But the decorator is taking place of the whole parameters in order to keep or maintain backwards compatibility. But basically, this actually works. I refactor this in this way, and this actually does the trick. But what happens is that my decorator is actually changing the signature of the function, because I define a function that takes 1 parameter, and my decorator is changing that for a function that takes 4 parameters. And it's applying a converted version to the wrap function. But this works. So far, so good. Now I identify the same scenario, but not in an isolated function, but in a method of a class. And I try to implement my decorator just as it is, and decorate the function in the same way. And I might think this is going to work. But actually, it doesn't work. Because based on what we just saw, methods are just functions that take 1 extra argument, which is the instance of the object itself. So basically, for the case of function, it's like everything is shifted 1 place to the left. Like the helper object is taking the place of self, and then nothing to take the place of helper. So basically, the decorator doesn't handle the case for methods. It doesn't account for self. So I might be tempted to actually try to solve this problem in really complicated ways, like trying to spec the signature of the function, or try to identify if the object is a method, etc. But there's also a much nicer way of doing so, which is the same way that Python solves the problem of making functions be able to work as methods. So in the same way that Python solves the problem, I can solve mine, and I only need to implement underget in my decorator. And it's going to receive, again, the instance, which is the object that is being applied to. And what it's going to do is going to call underget instead of the function being wrapped, which is going to convert the function to the method, and then going to re-trigger the decorator with a newly created method, and this time it's going to work. So in just 2 lines of code, I solve an otherwise hard problem. Another cool thing we can do with descriptors is that we can apply all sorts of object-oriented design, inheritance, composition, etc., because in the end, they're just classes and regular objects. So basically, for example, imagine that you need something like needs the functionality of example 1 and the third example combined. You can create a new class that is going to extend the class of the date formatter and the class of the protect attribute. Because in Python we have multiple inheritance, it's going to inherit under get from one class and under set and then delete from the other. And we created a higher level descriptor. So we can create hierarchies of descriptor, we can create even more advanced descriptors, etc. And perhaps even new design patterns can emerge from descriptors, because in the end they are just objects. This is something we saw in the first example, basically that they can work as general properties. We saw that properties are in terms like a particular case of descriptors. So when you have a scenario in which you are defining a property and you have to do it many, many times, perhaps that's a good hint that you have to use a descriptor and put the logic in 1 place only. Another cool use we can make of descriptors is like help on debugging. For example, since we can inject transparently so the way things are set or modified in an object, imagine that you have an object and you know who's changing a value of that attribute and you don't know why, you can create a descriptor to that and add traceability and trace or log when that value is being modified, and actually we will know which object is changing that value, which is very nice. So basically, to wrap up, we can say some things about descriptors and what we have seen. Basically, it's a good idea to implement as less methods as possible. So we have seen that when we list the the protocol, that partial implementation is not only okay, is perhaps desirable because if you implement less methods, first for object-oriented principles, the less method you have, the less coupled your object will be, and the more reusable it will become. But also, they will run faster because Python will have to check for less methods in all the logic, and as a result of that, you will gain performance. So try to get away with as less methods as possible. For example, if a descriptor will try to return the name of an attribute and it's the same as it appears in the dictionary of the class, there's no need to implement under get. For example, yeah, if I have something that is called X and it appears the same in the dictionary of the class, I don't need to implement under get and return the same value. And in general, they should be used for general purpose solutions. Basically, this is not for one-time thing because this is a feature more oriented to towards building frameworks or libraries, and you will find that actually many frameworks use, for example, SQL Alchemy uses descriptors. So if you can get away with just by using a property, that's preferably. And you have to take or keep in mind descriptors when you actually know that you're saving a lot of code. And generally, when you want to design an API, something that will have users relying on your code or being used by the methods you expose. So basically, that's it. I want to thank the organizers for having me here, and I want to thank you very much. And please do let me know the questions you might have. That's it.
Okay, thank you. We didn't get any questions on Slido. Do we have any questions from the audience?
Hi. I would like to know if you can give a rough idea of when not to use that or when go with another of the other two options that you gave for achieving this.
When not to use descriptors?
Yeah, exactly.
For example, when you have to do something that you can do with a property, for example. Something that you can do and a property is just fine and you need to reuse that, then it's preferable to use a property. And you should use descriptors if you have like the same logic and you have to define, okay, I need to put like 5 properties and they are all doing the same. That's probably a case for a descriptor.
Thanks. Anybody else? So maybe people are not asking because this was a lot of information to take in half an hour. Is there a good place on the internet?
Yeah, I'll upload the resources, so I'll let you know and comment. Yeah,
right. Thanks.
I'll put the link on the slides and the source code as well.
Thank you. Any more questions? Okay. Well, thank you.
Okay.